So we've talked about how to calculate the work done by a constant force. And the constant force that we know best is the gravitational force near the surface of the Earth. So we know that in our using our equation to calculate the work done by a constant force, we can calculate the work done by the gravitational force is equal to the magnitude of the gravitational force times the magnitude of the displacement that the object moves through times the cosine of the angle between those two vectors. So if I have an object that starts up high and moves downward, so for an object that moves down, I know that the gravitational force points down, the displacement points down. Since those two things point in the same direction, the angle phi between those two vectors is going to be 0, and therefore the gravitational force will do positive work. If I've got an object that moves upwards, then the gravitational force is pointing down, but the displacement now points up. So the gravitational force and the displacement point in opposite directions, which means the angle between those two vectors is now 180 degrees, and cosine of 180 degrees is negative 1. So I know that the work done by the gravitational force will be negative for an object moving upwards. So gravity does positive work when objects move down, negative work when objects move up. If I take my object and just sort of move it around randomly, well, again, I know that because the gravitational force points down, that there are only going to be special parts of this displacement that I actually care about. So I can break this displacement up into a vertical component that the gravitational force will care about in terms of doing work, and a horizontal component that it won't. So when I go to calculate the work done by the gravitational force, what I'm going to get is this expression. And so there's a couple significant details that are sort of hidden in here. One is, again, this is negative, mass is positive, this is positive 9.8 meters per second squared, so g is a positively valued thing, and then whether we use a positive or negative comes from our vertical displacement. So we've sort of built this equation so that when we move upwards, we have a positive vertical displacement. When we move down, we have a negative vertical displacement. So a negative vertical displacement, when an object moves down, will cancel out this minus sign and give me positive work, which is what I know I have to have. So this will give me positive work done by gravity for an object moving down, negative work done by gravity for an object moving up. Again, object moving up, my vertical displacement is positive, positive, positive. The minus sign stays, so negative work. Because this is still sort of hiding a vector thing inside a scalar thing, what I'll choose to do in class is to basically deal with the work done by gravity this way. I'll say, well, I'm going to take care of the plus or minus because it's easy to know whether an object is moving up or down. And so if an object moves down, I'm going to use the positive sign. If an object moves up, I'm going to use the negative sign. And then I'm just going to multiply together three positive scalar things. So the mass, the magnitude of the gravitational acceleration, and a vertical distance that my object moves. So all three of these things are positive, and I'm just going to take care of the sign out front. So to me, this is the easiest way to make sure that I don't make any sign errors in calculating the gravitational force, is just deal with the sign out front on my own, because it's easy to know whether an object is moving up or down.